Okay, so we're getting ready to prepare to actually start working on the lab at this point in the second video. So what we've already mentioned is that my 0.1-ish hydrochloric acid solution is already made. Check. I don't have to worry about that. My 0.1 molarity NaOH solution is also pre-made. I don't have to worry about that either. That will be ready in the jug when I need it. And under the NaOH, the directions tell me to standardize the sodium hydroxide. Well, that's going to be done as well for me. I will know the concentration of sodium hydroxide already by the time that I get into the lab. We've done that for you to save some time. What you need to start with is, again, the hydrochloric acid. It tells me 0.1 is the molarity, but I can't believe that. I don't believe myself, much less someone else. So I need to standardize my hydrochloric acid solution that somebody has made for me. So this is where we are going to start. So this is in part B of the lab experiment, and this is about step number 8 if you are following this lab in your lab manual. So step number 8 is where we are picking up and actually beginning this lab. Alright, so yet again, I've got this burette, and this burette has a stopcock on it, and it's graduated, and I'm going to fill this burette full of my titrant. And my titrant here is going to be my sodium hydroxide. NaOH is going to go into this flask, or into the graduated cylinder. Okay, down below, I'm going to have an Erlenmeyer flask. And this is going to have my hydrochloric acid solution in it. Now, if you read the directions, it says that they want you to do 30 milliliters of the hydrochloric acid solution into the Erlenmeyer flask. Add 70 mils of water and 5 drops of bromophenol blue solution. Okay, that's way too much. You do not need that much solution to titrate this. I mean, 70 milliliters of water and 30 milliliters of acid, that's wasteful. And look at this. 0.1 to 0.1, they're equal concentration. So ideally, if I got 30 mils of acid in this flask, it's probably going to take about 30 milliliters of sodium hydroxide to titrate it. So why would I go through all of that mess? I don't want to, okay? So we're going to scale back these proportions. Instead of doing the proportions that they tell you in the lab, instead of taking 30 milliliters of hydrochloric, we're going to take 10 milliliters of hydrochloric acid. Instead of taking 70 milliliters of water, well, we're going to take about a third. So half of 70 is about 35. If I do another half of 30-ish, we're looking at 15-ish. So if that's a fourth, so a third is going to be about 20 mils. Give or take, it doesn't really matter. Who cares? We're just going to add some water. And then it's going to say add a couple of drops of bromophenol blue. 3 to 5 drops should be sufficient for this procedure. So bromophenol blue. And I spelled phenol wrong. This is just the different type of indicator that changes different colors. And we like for you to use different indicators because we want you to know that there's other things out there that do this job the way that you need it to be done. What will happen is that under acidic conditions, bromophenol blue will be a yellow color. And then when it goes to base, it changes color. Very similar to phenolphthalein, clear to pink. But bromophenol blue goes from yellow to a blue color. That's why they call it bromophenol blue. Get it? Okay. So you're going to titrate this just like the sodium hydroxide in a previous lab, right? Instead of KHP down here at the bottom, you are putting hydrochloric acid down here in the bottom. You're going to be adding a little bit of water to it, just like you did the KHP in the previous lab. You're going to add a couple of drops of indicator, just like you did in the previous lab. And you are going to begin to titrate this solution with your sodium hydroxide. And the point at which it goes from yellow to blue is the point at which you stop. And you record that volume. That volume is very important because this allows you to calculate the true concentration of hydrochloric acid. And that is what we're after. So this is all volume based. You want to make sure that you do not over titrate this because this is going to play a big importance in your calculations later on down the road. So that is the standardization of hydrochloric acid. You're going to do this 3 times. That way you can get at least an average. The directions say also calculate a standard deviation. We do not want you to calculate a standard deviation though. Do not do that. Excel can do that very easily for you. There is a standard deviation formula built into Excel where you can just type in STDEV and then it will do the standard deviation. But we're going to hold off on that. We're going to wait off. We're going to hold it. We'll save it to another day. Titration's good enough for us at this point. So this is the standardization of hydrochloric acid. You have got to do this first. We have done the sodium hydroxide for you. You have got to do the actual standardization for the acid. So before you do anything with your antacids at all, period, you have to do this first. All right? Okay, so that's where this video is going to stop. In the next video, we're going to talk about how to handle the antacids now. What do we need to do with the antacids in order to titrate them? Because if you're telling me an antacid is going to be a base, then how on earth can I put a base here in the flask and a base here in the burette and titrate the two together? That doesn't quite work, does it? A base titrating against a base? So there's a trick that we do, and that is what the next video is going to be all about. Stay tuned.